Hey everyone, welcome back to stream number 30, the third Devlog stream. So last stream, recommend you go ahead and watch that. We got a good bit of progress done, like an hour and a half long. See what we can do now. So, wait, never mind. Alrighty, so let's go ahead and start. Oh, a new script already, wow.
We've added a variable to our vehicle, so if you select the vehicle in the inspector, you can see that speed variable under the script. Now when we press play, we can actually click on that speed variable, drag it, and we can control the speed, so we've got some good control, but our camera is still locked in the same place, so we want to make it so we can actually follow the player as they move back and forth. To do that, we'll create a new script. So underneath your assets folder in your project window, if you go down to scripts, right click on scripts, create a new C# script. We're going to name this script follow player because this will attach to our main camera and the behavior will be that the camera will follow the player. Make sure you name it correctly with the capital F and the capital P with no spaces. And then we're going to left click on follow player and drag it onto our main camera. Now if we click on our main camera in our hierarchy, you can see the follow player script has been applied as a component. So now we're going to open our follow player script by double clicking on it. So now our script has opened in our IDE, and what we're going to do is we're going to use public variables, but in a very different way this time. So what we can do is we can actually get a public variable, and what we're going to do is we're actually going to use a class or a type, in this case a game object. And so like I said before, things like our obstacle or our vehicle are game objects in our project, and so actually we can get references directly to our different game objects like our player. If we check in Unity, you can see now on our follow player script, it's added this line of code. If we select our main camera in the hierarchy, you can see that the follow player script has this player variable and it's looking for a reference to a game object now. And so in fact, we can actually left click and drag our vehicle from our hierarchy into that box, and now our player variable is tied to our vehicle. This is one way that you can get a reference to an object in the scene for another object to use. In this case, our main camera to use the vehicle. So variables can be used in really powerful ways, not just to store numbers, but to store references to other things that already exist in our game. Now what we're going to do is we can do a really interesting thing where we can actually get the transform. So this gets us the current transform component of the game object that this script is applied to, in this case our camera. So we get our camera's transform, and we can actually just get its position overall. And so this will give us the X, the Y, and the Z of where our camera currently is. Now we're going to use that equal sign, that assignment operator. We are going to set our camera's position. Now that we have a reference to our player, we can actually use player. The player also has a transform component, and we can actually get that position from the player's transform component. And then if we semicolon to end our statement here and make sure we save, so now our camera's position will be set to the player's current position. So now, if I press play and you watch in the scene view, watch our camera and our camera should be set to the position of our vehicle. There you go. Kind of works. It's underneath the car, which is close enough to what we want for now, so we can watch it as it drives down the road, runs into the different boxes. Cool little perspective. So what you're going to do is, in Unity, make sure you go to your project window, right-click on scripts. You're going to create a new script, a C# script. You're going to name it follow player, capital F, no space, capital P, and then you can left click and drag it onto your main camera, or just add it as a component using that little handy button in our inspector for the main camera. You're then going to open up the follow player script by double clicking on it. In our follow player script, you're then going to create a new variable. This time it will also be public, but this time it'll be a game object variable. So that will be the type of variable that we're creating, and we're going to call it player. So that'll be the name. And then in our update method, add this line of code. So you get the camera's current transform position, and you're going to set that to the current position of our player's transform component. And then last but not least, a really easy step to forget is make sure you select your main camera in the hierarchy. In the inspector, you can see on the follow player script, there's a player variable that has no game object attached. So you're going to make sure you left click on the vehicle in your hierarchy and drag it into that box. So then your player variable is assigned to the vehicle in our scene. So then when you press play, you can watch it as it drives down all the way down the road. Now it's your turn.
Alrighty. So we're gonna go to double checking. Alrighty. Made a mistake, not transform. Translate. Oh. Okay. P-O-S-I-T-I-O-N. Wondering why it didn't work. I didn't watch the video. It's called... I am not sure what I just did. Bonk, bonk, bonk. And then... Goodbye. Looking good. Very good. Probably some multiplication going on.
Our camera is now positioned. Unfortunately, it positions underneath the vehicle, which is an interesting perspective, but not exactly what we're looking for. We actually want to create the same effect that we have in our camera here in our preview, so that way we're following behind the player instead of underneath the vehicle. So we'll change that perspective using some of our code. And then what we're going to do is where we're actually setting our camera's position to our player's position, this is actually where we're going to add to our player's position so that we can offset our camera above and behind our player. Fortunately, we already did some of this work before, so luckily the player vehicle is at 0, 0, 0. And then what we did with our camera is we actually put it at 5 on the Y and -7 on the Z, so it went up and then it went behind our player here. So we can actually use those values to be able to reposition our camera behind the player when the game starts. So using our update method, since we're constantly keeping track of the player's position, we want to add, in this case we just use a plus sign like you would on a calculator, and then we should add, I believe it was 0 and up 5 meters,
5
and
and then
then
-7.
back 7 meters, so -7. So that doesn't seem to work. So let's see. I believe the problem is, so in fact, our player's position is giving us a vector 3. And here, although this would make sense in our heads, this doesn't make sense to our computer at all. Our program is trying to add some statement that doesn't exist, and it's trying to add it into our vector 3. So what we actually need to do is we need to add two vector 3s together. So we actually need to create a new vector 3, and we're going to use the keyword new because we're actually creating a new vector 3 instance. We're not creating a vector 3 variable that we're storing or saving. Since this is just temporary, we use new vector 3. And so now this will actually create a new vector 3 just for this line of code that'll have the values of 0 on the X, 5 in the Y, and -7 on the Z. Last but not least, we're going to add a comment to our code. So we're going to say offset the camera behind the player by adding to the player's position. Now we make sure we save. So now if we test our game, we should see that our camera is just following the vehicle. Awesome. So now we have a much better view of where we're driving and where we're going. So what you're going to do is in your camera's position, where you set it to be the player's position, you're just going to add a new vector 3 with the values of 0, 5, and -7. Now it's your turn.
Easy enough. Zero, comma space 5, comma space -7. I see it actually coming along. Oh! Oh, and sideways. Oh no! No! And down she goes. And then she's gonna go through the skybox. And then this is gonna fall forever and forever and forever. Try that again. Perfect. Variable, that should be pretty easy.
Now our camera is positioned perfectly behind our vehicle as it drives down the scene. What we're going to do is we're just going to clean up our code just a little bit to make it easier to understand. In our follow player script, I mentioned that it's really bad to have hard-coded values. So we're actually going to take this vector 3 we've created and create a variable for it. So this one will make a private variable, so it can only be used inside of this class. So I'm just going to use the keyword private here so you can see how it's used. Very similar to a public variable. And for this, because we're making a vector 3, we need to make this variable a type of vector 3, and we'll call it the offset. Now we set this variable to be this value here. So in fact, we can just cut by Control or Command X with the code highlighted, and then we go to where we had the offset and we paste with Control or Command V. So now our offset vector variable is being set to that new vector that we made before with our offset position already added to it. So now in our update method, we can just add where we removed that bit of code, the word offset, and because offset is a vector 3 being added onto a vector 3, then we can set our position properly. Make sure you save, go back into Unity, and press play, and you should see that nothing has changed, which is exactly what we wanted to happen. So what you're going to do is in your follow player script, you're going to create some of variables of your own. You're going to make a private vector 3 variable called offset, and you're going to initialize it by assigning it that new vector 3 offset that we had created down in our update method. And then you're going to remove that new vector 3 line and just replace it with the word offset. So that way, it's always just using the offset variable, and if we ever need to change our offset numbers, we can just do that here at the top of
Like,
our
why
code.
don't you just make a
And then
public?
just make sure that
Make
you
do it
press
in
play
Unity.
and test to see that it's working exactly like it should. Now it's your turn.
Okay. That's simple as. Yeah, nothing happened. Perfect. I have noticed that. Let's fix that.
Okay, now that we have our camera following our vehicle properly, you might notice that there's a weird effect happening with the vehicle itself where it's kind of stuttering back and forth. And so we can make one small change to our follow player script to make our vehicle move super smoothly. Now, essentially what's happening is in our update method, our vehicle and our camera are both moving at the same time. So sometimes the vehicle might move first and then the camera might move, but other times the camera might move and then the vehicle will move, and so it creates this stuttering effect. A simple thing that we can do with our update method is change it to late update with a capital L, make sure there's no space so it's all one word. And with this late update method, essentially what it will do is update after our update method happens. So if you remember, for our vehicle, it's moving through the update method, constantly moving forward, and then late update is called, which will then move our camera after the vehicle is moved. So if I save this script using Control S or Command S on a Mac, head back over to Unity and then test out our script to see if it works, we'll press play, and you can see now that the vehicle is moving much smoother because of that late update method, where the vehicle moves first and then late update happens, making the camera move to follow the vehicle. So what you're going to do is head into your follow player script, and where update is, we're going to change that to late update with a capital L and a capital U, no space, so it's all one word. Once you've changed update to late update, make sure to save your script using Control or Command S. Head back into Unity and test out your project using the play button, and you should no longer see your vehicle stuttering in your camera frame. Now it's your turn.
Yeah, I'll finish it in 1 second. Done. Does he have his X? Like, does he have like X like Is this X that moves? Like rotation? Rotation on the Y. My car actually has a ramp on the front of it too. His model doesn't have like remember it used to not have this. It never had this like ramp right here. They must have added this like really recently. Like this ramp was never here. Never seen that. But yeah, I unlocked the Y, so it's actually more like his.
Our camera is now well set up in our game to be behind the player, and we even added in some variables to make our code more organized. Now we're actually going to fiddle around with our Unity interface again, just like we changed the layout, but this time with a very helpful tip to know when you're playing your game. So you can see when you play the game, your interface goes from a light gray to a dark gray, which is helpful, but not entirely visible. So I'm going to show you a cool little trick that I do, so it's really easy for me to know when I'm in play mode. At the very top left of Unity, there's an edit button. If you're on Mac, there will be a Unity button, and then you click Preferences. From my edit menu, I have a Preferences option as well. Now, in our preferences, we have all of these different options. Right now we're on General. There's one down here called Colors, and specifically, there's an option here called Play Mode Tint. So this is actually what controls the tint of our interface when we're in play mode. So, if I select this by clicking on it, you see it brings up a color picker. So you can pick colors yourself, you can move it around, you can change the opacity so that it's more clear, or if you want it to be really dark and really visible, entirely up to you. So I have a setting that I like to use, so I'm just going to type in values for myself. So 157, 194, 239, and then we'll make this like 150. So now I should have a fairly transparent light blue. So I can close out of my preferences. You can see that it actually saves it immediately when you set that color. Close out of the preferences. Now when I press play, you should see a bluish tint pop up over all of my window. So that's super helpful. So now I know when I'm editing values, if I'm in play mode or if I'm in my scene. And so that way I don't accidentally change something that just gets reset and then I don't remember what the value is. So very helpful tip, just something to make your life a little bit easier as you're testing your game out and trying to figure out why, for example, if you click on something, it's not moving or whatever. So what you're going to do is in the top left of your editor, you're going to see an edit or a Unity button. Click on that. Go down to preferences, click on that. You'll see this preferences window pop up. You can click on the colors option. Under the colors, the very first one under general should be play mode tint. If you click on that, you can select different colors. You can change the opacity. And then when you exit, it saves your color. You can exit out of preferences. So then when you play your game, you can see when you've entered play mode, which is really handy. So now it's your turn.
Is it just me, or does it look like the whole screen says covered in a thin layer of blood? It looks like it's covered in a thin layer of blood. That's fine and all, but that's way bloody. That's really bloody. Do that. Let's do. Too fast. If that's less bloody. This is even bloodier. Oh my gosh. Phew. My bad. That still looks like a bloodbath. There you go, I can see right through it. I would say though, maybe do preferences. Oh, that just looks like pee. It looks straight up pee. I don't want pee. And last one. Yeah, crunchy.
So our game is in a pretty good place now. We have our camera that follows behind the player as it's offset. So that's some cool functionality that we've added. We've also gained a lot more programming knowledge. In our follow player script, we learned how to use our first public variable, in this case, so that we can actually attach a reference to our player in Unity. We learned that variables also don't have to just be numbers. They can be game objects, or they can be vector 3s. They can be of whatever type they want, as long as you make sure that you assign the same thing to the type of variable that you have. So we have a vector 3 offset, and we assigned it to a vector 3. We learned about the difference between access modifiers, like the public and the private keyword, so that we're able to interact with and use these variables in different ways, inside and outside of our script. We also learned how to initialize our variables. Now, in the next lesson, we'll add our last lines of code so that we can really control this player as they drive down the road and help turn around all these different obstacles so we don't just keep pushing them all the way down. See you in the next lesson.
Another milestone complete. Ooh.
welcome to Challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this vehicle that can drive forward and these boxes that have physics and collisions in it, and we can fully control this vehicle, turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game, and if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed.
Ah, there you go. That's bad to say it, but this is much better.
The vehicle in our prototype is currently a very low-end, very dangerous self-driving car. You click run, and the car rockets off on its own, crashing into every obstacle along the way. Not necessarily the kind of car you'd want to be a passenger in. So it's about time we let the player step into the driver's seat and take the wheel. By the end of this lesson, the player will be able to control the acceleration and direction of the vehicle using the arrow keys on the keyboard. The vehicle should move forward when the up arrow key is pressed, and backwards when the down arrow key is pressed. Luckily, Unity has an entire input system set up to help us do exactly that. When you press the up arrow, you get an input value of +1, and when you press the down arrow, you get an input value of -1. So let's say we set the vehicle speed to 10. All you have to do is multiply that speed by the input value and you're good to go. When the player presses the up arrow, it'll multiply 10 by +1, giving you +10, moving that vehicle in the positive forward direction. But if they press the down arrow, it'll multiply 10 by -1, giving you -10, moving the vehicle in the negative backward direction. Then you can basically use the same type of system to rotate the vehicle. You multiply the rotation by a positive value if they press the right arrow, turning the vehicle right, and multiply by a negative value if they press the left arrow, turning the vehicle left. Just some simple multiplication, and you've got full control of this vehicle. So to make all that happen, I'll see you in Unity. Our vehicle drives down the scene now, and when we press play, we have this nice tint to show us that we're in play mode, and we have our camera following, but right now, we still can't really control our vehicle. It just drives all the way down the road, just running all these obstacles over, pushing them off, and then eventually it gets to the end of the road, and then it just falls straight off. That's just because there's not an end there, but we need to be able to control this vehicle's movement. So first we need to be able to move our vehicle so that it avoids the obstacles. If we open our player controller script, we're going to need a way to control our vehicle to move left or right, so we should probably just use a variable to do that, since we know it's probably pretty bad to just use a random number. So good to think ahead in general. We're going to make this a public variable so that we can control it just like we did with the speed. It will also be a float because we'll be using decimal points. And then we're just going to call it turn, lowercase t, capital S for speed. So you can see here turn speed has different capitalization. So this is a very standard, what is called a naming convention when you're programming. So for variables, we often use lowercase letters like speed, turn speed, even transform is a variable to be able to very easily see when we're using a class or when we're using an object, when we're using methods, or when we're just using variables. Now we want to be able to move our vehicle left or right, so we'll do something similar to what we did with our transform.translate. instead of a vector 3 forward, we can actually use, there's a whole bunch of other options for vector 3, so we can actually use like right. So this will move our vehicle in the right direction. Again, we're going to multiply by time dot delta time because we want to be able to update this position over time instead of once every frame. And then we multiply by that handy turn speed variable that we made before. So now in our game, if we take a look down at our game view and we select our vehicle so we can see the values, if
Yeah.
we press play,
What are you streaming?
nothing's happening. Well, that's actually
Are you,
because
like,
we're
playing a
multiplying
game
by
and
a
streaming?
0.
No, I'm
So actually,
coding.
if we click on turn speed
It's the
and
devlog for my
drag it to
game.
the right, it'll actually start turning right if it's positive. If we go to the left, it'll start going to the left because the value's negative. So, easy way to see how we can move our vehicle left or right. Now that's great, but we'll need to be able to also control it as well. But first, what you're going to do, in your player controller script, create your own turn speed variable. We'll make it public so we can play around with it in the editor. Make it a float because it will be a decimal value. And then in your update method, we're going to add another transform. This time we're translating with vector 3 right. So we're using our right vector. And then we multiply it by time so that way it updates over time instead of every frame. And then we multiply it by our turn speed variable. So then when we play, if we click on our vehicle in the hierarchy, we can actually click and drag the turn speed so that it moves left and right. Now it's your turn.
Alrighty, this is easy. Right. Ah, my bad. And unfree that rotation as well.
Our player can now drive down the road and we can change the speed of its movement. We can even change the speed of its turn. However, if our player is actually playing the game, we don't want to be able to fly off the road, for one,
Oh, wait.
but also, if our player is using like a joystick or something, we can't just
Nothing.
be dragging this variable around. We can't do this for
I'm not editing
a single
anything.
player, like it's magic behind the scenes.
No, it's not. I'm streaming.
So, we're going to create some actual magic so that the player can actually
Streaming me
control
coding.
their own movement. A very helpful thing to know before we
My new
get
Tycoon
into
that I came up
programming this
with. Have you not
is
seen my video?
understanding that Unity
not
does
seen
a
my
lot of
videos?
things that make our lives a lot easier. So, in fact, if you go to the top left, under Edit, or if you're on Mac, under Unity, if you go down
Check
to
my
Project
YouTube channel. I
Settings,
made a
and you click
devlog.
on that,
Check there.
there's all these options for project settings, but what we really care about is actually our
What?
input. So this is actually our input
sussy?
manager in Unity,
What?
and they've helpfully already
Also,
created a
you're very
way
sus.
where when you do something, it's already mapped to be able to change that value. So if you left click on the drop down on axes, you can see there's different ones, like there's actually fire button, so you can actually press like the left control button to fire something, or a second option, left alt, left shift. There's a jump, which is the space bar. You can take a look at all of these different options, but what we're looking for specifically are actually these horizontal and vertical axes. And so this is actually how Unity knows if we want it to go left or if we want it to go right. Using these horizontal axes, we can actually see those values change and how they change. You can see that there's inputs for the left arrow key to go negative or the right arrow key to go positive. There's also alternative buttons for using the A key to go negative or the D key to go positive, and it's called the horizontal axis. Knowing this, we can do something really easy to be able to control the player's movement. In our player controller class, first we're going to create a public variable so we can actually watch and see what it's doing. And this will be a float again, and we'll call this horizontal input, because this is actually the input that we'll be tracking on our horizontal axis, left or right. And then what we need to do is we actually need to set this variable, which we'll do inside of our code. So we'll actually do this in our update method. So we use our horizontal input, we call our variable, and then we use the equal sign. So we're going to assign this variable some value. And now if you remember that input manager, so there's actually a class and a method that we can call just for that input manager. So if we type capital INPUT, so this is our input manager, it's called input. So now that we have our input manager class, if we type dot, and then we were looking for that axis before, so we can actually use our getAxis method. So this will give us the values for when we press the left or right key on that axis, but we also need to tell it which axis we want to use, and in this case it's asking for the name of our axis, specifically a string. Now a string is a way for your computer or program to create a word that is literally interpreted by the computer and easily understandable for us. So, for example, if I in here actually type in a double quote, you can see it actually auto-completes a double quote for me at the end. So this is creating a string literal inside of these quotes. So it'll literally interpret anything that I put in. I could literally say hello world, which is very helpful if I'm trying to, for example, print something, or I need the program to tell me an error that's happening or something like that. Using string literals can be helpful in that sense. For this, we actually type in the word horizontal, because in Unity, in our input manager, the name of our horizontal axis is just horizontal. So now we're getting the input for whenever a player presses the left or right key. And then last but not least, we need to actually go into our translate and multiply this by our horizontal input. So now if you make sure you save, we can close out of our project settings. And let's make sure we select that vehicle so we can actually see what's happening on the horizontal input. Our turn speed is set to 0, so we know that's not going to work. So we'll set it to 1 for now. And then if we press play, So we should see if we press the left arrow key, it slowly moves to the left. If we press the right key, it slowly moves to the right. And we can use the A key too if we want to use the other key. It'll move to the left. If we use our D key, it will slowly move to the right. So we know our input manager is working. You can even see the values change from -1 to +1. So that's a very handy way of understanding how your input manager works. As you press the left arrow key or the A key, horizontal input goes negative all the way to -1. Or if you press the D or the right arrow key, it goes to +1. So what you're going to do is you're going to add another public float variable called horizontal input. In your update method, you're going to call the horizontal input variable. You're going to set it to the input for our input manager. And you're going to get the axis that's horizontal, so we can get those left and right arrow keys. And then last but not least, in your transform.translate, you're going to multiply the entire equation by our horizontal input. Now it's your turn.
me check edit. I did nothing wrong. I did nothing wrong. Wait, am I an idiot? Do I not have? I do not have turn speed on. I'm an idiot. I never had turn speed on. No, it was fine. I just didn't have turn speed on. Also.
Our vehicle can now move to the left or the right. Looks a little weird, but we'll fix that later. Problem is, we keep moving forward, and I want to be able to control that too. Just to make it a little bit more interactive. So, if we take a look at our input manager again, in the top left, if you click Edit or Unity, go to Project Settings. Select the Input option, and then make sure to expand the axes. In this case, I'll collapse our horizontal axis. You can see the vertical axis here with the name vertical and uses down for negative, up for positive. So we can do the same thing that we did with our horizontal input and do that with our vertical input. In our player controller script, we're going to create another variable. We'll make it public as well so we can see it. We'll make it a float because we need decimals, and we'll call this forward input to control our movement forwards or backwards. Similar to what we did with our horizontal input, we'll create a new line. We use our forward input, and we're going to set this to our input manager. .get axis, use quotes to create a string literal, and then we use vertical. And then we will change in our translate method for moving forward. We'll just multiply by our vertical input. Our forward input, I should say. So now in Unity, if we close the project settings and then we press play, we should see hopefully our vehicle doesn't move at all. Cool. And then if I press the forward arrow, it moves forward. If I press the backwards arrow, it moves backwards. Same thing with W, moves forwards. S moves backwards. And then I can even move forwards and move to the left at the same time. I can move to the right with the arrow key. I can even go backwards. Make it really challenging for myself. Can't see the boxes. And then we still have this weird issue where our vehicle can move side to side, but we'll fix that later. But we've got player movement down. So that's really handy. Now we can give our players full control of our game. An especially cool thing to note about the input manager is that this can actually understand input from a variety of different places. So for example, if your player was using a controller, then you can actually get the input,
Okay,
for
so
example, from their joysticks
I wanna make the game
to
now.
know when they're moving to the left or right, or forwards or backwards. So the input manager is a very helpful way to be able to get information from the different kinds of input, whether it's a keyboard, or it's your mouse, or it's a controller, different things to make your life a little bit easier. So what you're gonna do in your player controller script, create a new variable, a public float variable called forward input. In your update method, you can add a new line of code similar to our horizontal input. We'll call it forward input, and we make sure to get the axis of our vertical axis. And then in our transform.translate, where we are moving forward, we'll just multiply everything by our forward input. And then in Unity, when you press play, you can test out your movement in your vehicle. Now it's your turn.
Alrighty. So I actually want to go ahead and make the log tycoon. I'm gonna save Unity. So close this, right? And then we'll go back into the Unity hub. And now we're gonna make a new project. 3D game. I'm gonna name this log tycoon. Yes, my friends, this is the start of log tycoon. I'll move it in a sec. Wait for that load. Alright. Alrighty. Ready? So, we're in. First things first. Let's go ahead and get my layout. First of all. Now let's go ahead and start off. First of all, I want a award. So let's get like a game object, a block or something. Let's go to sample scene. It's gonna make a new 3D object. Still plain. There we go. Reset it to 0, 0. Let's do 10 by 10. Don't do it on the Z unless it just makes it thicker. That's a good enough player, yeah. Now let's get a player. Do capsule. Right above. There we go. And the camera. Let's make this a different color. There we go. It's a broken glitch that makes my page full. Oh gosh. 0.5. 1. It's fine. It's fine. Alrighty. So let's do a public float. play a movement player. Speed. Public. Float. Turn speed. Yeah, I was trying to translate. Now let's go ahead and add him. Alrighty, so that there's all the values. That's player speed, the turn speed. Okay, that should be all good. That should be basic enough that. Hmm, This should be basic player movement, if I'm correct. That's right. My bad. My bad. Do not work because it needs to be attached to anything. Aha. I'm not named this, so. Now we need a V variable. I should probably make it private. What am I doing? Hmm. Actually, I don't know if I'll be doing this more often because it's harder with like the scripting and all that. What are you gonna say? Camera. 4.5 and -5. Was that? Wrong negative. That should be negative. I'd highly doubt. That's because camera. I do not have a public variable for camera. That's my bad. Did not give me a public game object player. Is this public game object? Oh, plus, not times. Because it's not giving me my variables. My variables aren't showing up. It's public. public game. Probably skipped. No, game object is correct. No, I'm done. I'll debug this tomorrow. Hope you guys enjoyed the stream. I'll probably end up, I don't know if I end up doing this more often, but anyways, hope you guys have a great day. And say, guys,